Hi, today we're going to be learning about proving that two triangles are similar to each other. First, I want to remind you what we mean by similarity. For similarity, we use the symbol that looks like this, with three vertical lines next to each other. When we say that two shapes are similar to each other, it means that they are proportional to each other. That means that they have the same shape, their corresponding angles are the same as each other, they're equal, but they are different sizes. Their corresponding sides are in proportion rather than being equal. So in this example, I can say that triangle ABC is similar to triangle DEF. Okay, now when we are naming similar shapes, we have to name them in the correct order, just like we do with congruent shapes. We have to name them based on the angles that are the same size. So like in this example over here, if angle A is equal to angle F, then if I write A first, I have to write F first for the two triangles. If angle B is equal to angle D, then if I write B second, I have to write D second. If angle C is equal to angle E, then if I write C third, I have to write E third as well. So I have to name them in the correct order. Then if it's named in the correct order, I can then see based on those names which angles are equal to each other. So you can see over here, if A is first and F is first, it means that A is equal to F. If B is second and D is second, then B is equal to D. And if C is third and E is third, it means that C is equal to E, because they've been named correctly. And then if you check in the diagrams, you can see that as well. You can also see which sides are in proportion to each other. So over here, AB is proportional to FD. So I can say that AB is equal to FD multiplied by K. Remember we said that they're not equal to each other, they are proportional to each other. Over here, BC and DE are proportional, so I can say BC is equal to DE multiplied by K, and AC is proportional to FE, so AC equals FE multiplied by K. So over here, K is the proportionality constant. In this example over here, if you look at them, I've got X and 2X, Y and 2Y, Z and 2Z. So my proportionality constant for this example would be 2, because if I multiply each side in this triangle by 2, I will get the length of each side in this triangle. So my proportionality constant is 2. Now another way of representing that these two triangles are in proportion is by taking all the sides in the one triangle and dividing them by all the sides, the corresponding sides in the other triangle, and showing that I get the same thing for each one. So over here, if I say AB divided by FD, like that over there, it'll be x over 2x, which is a half. If I take BC and divide it by DE, like over here, then y divided by 2y is a half. And AC divided by FE, z divided by 2z is a half. So as long as I take the same triangle at the top and the same triangle at the bottom for each of these, I will always get the same thing if these two shapes are similar to each other. In other words, if they are in proportion to each other. So if their sides are in proportion, then these fractions will always work out to the same thing. So these will always be equal to each other. Now let's have a look at the conditions for proving that two triangles are similar. The first condition that we can use is proving that the three angles in the one triangle match the three angles in the other triangle. So angle, angle, angle. This is a condition that we couldn't use for proving congruency, because when you're proving congruency, you have to know that at least one pair of sides is equal in the two triangles. Otherwise, you can't prove that they're congruent because you don't know what size the triangles are. But when you're proving similarity, they don't need to be the same size. They just need to be the same shape. So as long as you can prove that all three angles are the same as each other in the two triangles, then you can prove that the two triangles are similar. Another way of proving the two triangles are similar is to use the proportion of the sides. So to prove that the corresponding sides in the two triangles are in proportion to each other. Now we're going to go and practice identifying similar triangles. So in this example, we need to decide whether the following pair of triangles is similar. And if they are similar, we need to name them properly and state the condition for similarity. Okay, so if you look at this over here, triangle ABC and triangle DEF. If I want to prove that these two triangles are similar, I have to either prove using the angles or using the sides. Now in this case, I don't know anything about the sides, so it's definitely not going to be sides in proportion. It's going to be angles if they are similar. So let's have a look at what we know about the angles. So first of all, I know that angle A is the same as angle F, and I know that angle B is the same as angle E. So I've got two pairs of angles in the two triangles that are the same. Now, the thing about triangles is we know that the angles in triangles add up to 180 degrees. So if I know that two angles in this triangle are the same as two angles in that triangle, then the third angle in each triangle has to be the same by default because the two triangles both add up to the same amount. The angles in the two triangles both add up to the same amount. So even though I haven't actually been told explicitly that these two angles are equal to each other, I can say that they're equal because they are the third angle in the two triangles, and I already know that the other two angles in the two triangles are the same. Okay, so in this case, I can say that triangle ABC is similar to this triangle. So now I need to go and name it in the correct order. So if I say ABC, then A matches F, B matches E, and D matches C. So it's going to be ABC and FED. And my reason is angle, angle, angle. So even though I only had two angles in the two triangles, it's still angle, angle, angle because the third pair of angles is automatically equal if the other two pairs of angles are equal. Okay, so now I'm going to give you a few that you're going to do for yourself to practice determining whether or not triangles are similar and naming them properly and stating their condition for similarity. Okay, so here's the first one you're going to do. You're going to do the exact same thing as we did in the example. I'm going to give you 30 seconds to do it. Okay, so you should have found that these two triangles are similar. If you name this triangle ABC, then A is the same as D, B is the same as F, and C is the same as E. So you should have had ABC is similar to DFE, and our reason is angle, angle, angle. Right, here's the next one. Let's give you 30 seconds for this one as well. Okay, so once again, these two triangles are similar to each other. We don't know anything about the angles in these triangles, but we have been given information about the sides. We've been told that this is 3, and this is the same, so it's also 3, and that's 5. And here we've got 10, and then 6, and this is the same, so it's also 6. Now, if you look at the sides over here and the sides over here, they are in the same proportion. If I multiply these by 2, I will get these over here. So these two triangles are similar. So I can say that triangle GHI is similar to triangle JKL, and my reason is sides of the triangle are in proportion. Now, if you weren't sure how to do the naming of these two triangles, I recommend when you're working with similar triangles where you have sides are in proportion as your way of proving, then look at each angle and see what side it is opposite. The angles that are opposite the longest sides in the two triangles will be the matching angles. The angles opposite the shortest sides in the two triangles will match, and the angles opposite the medium sides in the two triangles will match. So over here, G is opposite one of the sides that are 3 long, and they are both shorter. And over here, the shorter sides are the 2 that are 6. Now, you could have had JKL like I have over here, or you could have had LKJ if you wanted as well. It doesn't matter which way you have because these are both the same length and these are both the same length. So these two angles will be the same size as each other over here because they're isosceles, and these two angles will be the same size as each other over here because they're isosceles. So you could have had JKL like I have here, or you could have LKJ as well. So when you are naming triangles for similarity, where you're proving it based on the sides being in proportion, name them according to the side that each angle is opposite. So match up the angles opposite the longest sides, match up the angles opposite the shortest sides, and match up the angles opposite the medium length sides. Okay, now we're going to go on to the next one. I'm going to give you 30 seconds for this one as well. Okay, so let's go through this one. So you should have found that these two triangles are not similar to each other. First of all, we don't know anything about the angles, so we can't work with angle, angle, angle. We would be working with sides in proportion. So if we look at the sides in these two triangles, you look at the longest side here is 27 and the longest one here is 17. The shortest side here is 18 and the shortest one is 8. Here the medium sized one is 25 and the middle one here is 15. Now, I can't multiply these by all the same thing to get these. The relationship between these sides and these sides is actually that we are adding 10 to these to get those. And that does not make them in proportion. In order for them to be in proportion, we have to be able to multiply all of these by the same thing to get these. And that's not the case over here. So these triangles are not similar. Right, question D. You have 30 seconds for this one as well. Okay, so now let's compare the longest side over here, which is 14, to the longest side over here, which is 21. The medium side over here, which is 12, to the medium one over here, which is 18, and the shortest one, which is 10, to the shortest one, which is 15. Now, I can't multiply by 2 or anything like that to get this, but what I can do is, if you look at this, 10 is 2/3 of 15. 12 is 2/3 of 18, and 14 is 2/3 of 21. So for each of these, if I multiply them by 2/3, I will get that. Or if I multiply each of these by 3/2, I will get that. Or if I divide by 2 and times by 3, I will get that. So these are in proportion. Okay, so now if I name them, it's going to be ABC. Triangle ABC is similar. Now remember I said you look at the longest side over here and you match it up to the longest side here. So A is opposite the longest side. So the one opposite the longest side over here is F. So F matches A. Then B is opposite the medium length side. So over here, the medium length side is going to be 18, which is E. So E is second. And then C is opposite the shortest side. So over here, D is opposite the shortest side, so it goes last as well. And our reason is sides of triangle in proportion. Right, question E. You have 30 seconds for this one as well. Okay, you should have found that these two triangles are not similar. We know that we have these angles that are the same as each other, and they are the same as this angle over here, but this angle is not the same. So I can't assume that these two triangles are similar. Now there is a possibility that this angle could be the same as that, and this angle could be the same as that, but we don't know. Because we don't have enough information, we cannot say that they are similar. So as far as we know, they are not similar. And then the last one for this activity, I'm going to give you 30 seconds for this one as well. Okay, you should have found that these two triangles are similar. If you look at it, I've got a right angle here and I've got a right angle there. These two angles are the same. Now these two angles over here may have confused you because this one has been marked and this one hasn't. But remember what we said in the example I did with you. If two pairs of angles in the two triangles are the same, then the third pair of angles in the two triangles has to be the same as well, because the angles in the two triangles both have to add up to 180 degrees. Okay, so these two triangles are similar. So I can say that triangle STU is similar to triangle YXZ. So triangle STU is similar to triangle YXZ, and my reason is angle, angle, angle. Okay, so now that we've practiced identifying whether or not triangles are similar and what their condition for similarity will be, now we're going to go and practice actually proving similarity. Here's our first example. In this example, we need to calculate the lengths of AC and ED. All measurements are in centimeters. Okay, so in order to calculate the lengths of AC and ED, I first have to prove that these two triangles are similar, and then I'll be able to use the fact that they're in proportion to work out what the lengths of these two sides are. Okay, so let's have a look at proving that they are similar first. Just like when we are proving the two triangles are congruent, we start off by naming the two triangles that we're going to be proving are similar. So I'm going to say in triangle ABC, and triangle over here, A matches E, so E goes first, B matches D, and C matches C. So in triangle ABC and triangle EDC, I need to have three statements, just like I do for congruency. So the proof for similarity is going to be very similar in its layout to the proof for congruency, especially when you're doing angle, angle, angle. Now over here, the angles that I know are the same are these two angles. They told me that is the same as that. And I can prove that these two angles are the same because they are vertically opposite. Okay, so I can say over here that angle A is equal to angle E. So angle A in triangle ABC is equal to angle E in triangle EDC. And the reason I know that is because they told me that those are equal, so that's given. Okay, then my next pair of angles are these angles over here, angle C1 and angle C2. And I know that they're equal because they are vertically opposite. And vertically opposite angles are equal to each other. Now, when you're proving similarity, you only actually need to know that two pairs of angles are equal, because the third pair of angles is going to be equal by default, because as I said earlier, the two triangles both have the same sum of their interior angles, which is 180 degrees. So over here, I can say now that angle B is equal to angle D. And I know that because it's the third angle of the triangle. Okay, so now I've got my three statements. Now I can go and say, therefore, triangle ABC is similar to triangle EDC, and my reason is angle, angle, angle. Okay, so now I've proved that these two triangles are similar. Now, just like when we're proving the two triangles are congruent, once you've done the proof, you can then use the fact that they're similar to draw conclusions. So because these triangles are similar, it means that their sides must be in proportion. So that means I can now say that AB, so therefore AB over, so this is where it's useful to make sure that they're in the same order, because in the correct order, because now I can say AB over ED is equal to BC over DC is equal to AC over EC. Now this I can say because the fact that they're similar means that the sides must be in proportion. Okay, so now I'm going to go and fill in the lengths of the sides that I know. So AB is 8. So that's going to be 8 over ED, I don't know, equals BC is 10 over DC, which is 20, equals AC is unknown, so that's going to be AC at the top, over EC, which is 7. Okay, so now I've got 3 fractions over here. 2 of them have an unknown in them, but one of them has got both values. So 10 and 20. I'm going to go and simplify that. So I can say 8 over ED equals 10 over 20 is the same as a half, equals AC over 7. Okay, so once I've got to this point, now I can go and work out what ED is by taking this fraction equal to the one where I know everything and making an equation out of that. So I'm just going to take those two equal to each other so I can work out what ED is. And then I will take these two equal to each other so I can work out what AC is. So now I can say 8 over ED is equal to a half. Okay, now I can go and work out what ED is by solving this equation. ED is my unknown, so I'm going to solve the equation. So now my LCD over here is 2ED. So I'm going to multiply by whatever is missing. Over here, I'm missing the 2, so I'm going to times by 2 at the top. So it's going to be 16 equals, and here I multiply by ED, so it's 1 ED. So now I know that ED is equal to 16. And that is centimeters because they told me that all the measurements are in centimeters. Okay, so now I've worked out what ED is. Now I'm going to go and do the same thing to work out AC. So I'm going to take the fraction that has AC equal to the fraction where I know everything. So I can say a half equals AC over 7. So once again, I need to find my LCD. So my LCD for 2 and 7 is going to be 14. So I'm going to multiply here by 7. And that gives me 7 equals, here I multiply by 2, so that's 2AC. And now I'm going to divide by 2 to find out what just AC is. So therefore, AC is equal to 7 divided by 2, which is 3.5 or 7 over 2. But I'm going to write it as 3,5. We normally will write, when we're working with things like distances and stuff, we'll normally write it in decimal form. So 3,5 centimeters. Okay, so that's what I get for AC. So to do this question, first I prove that the two triangles are similar. Then because they're similar, I can say that the sides must be in proportion. And because the sides are in proportion, I can then work out the lengths of missing sides. Okay, let's go on to the next example. In this example, we need to prove that VZ is parallel to XY. Now, before we do this question, what you need to know is that just like we're able to use parallel lines to find out the sizes of angles, using alternate angles or corresponding angles or co-interior angles, we can also go backwards and we can say if alternate angles are equal, the lines must be parallel. Or if corresponding angles are equal, the lines must be parallel. Or if co-interior angles are supplementary, the lines must be parallel. So that's the concept we're going to be using in this example. If I want to prove that these two lines are parallel, then I need to be able to prove that alternate angles are equal. So this angle and that angle are alternate to each other. If I can prove that those are equal, then I can prove that these two lines are parallel. Or if I can prove that these two angles are equal, because they're also alternate, then I can prove that these two lines are parallel. So my goal is to prove that the triangles are similar in order to prove that the angles are equal, so that I can then conclude that the lines must be parallel. Okay, so that is my goal here. So the first step is going to be proving that these two triangles are similar. Now in this case over here, I have been given all the lengths of the sides in these two triangles. So I'm going to be using proportion to prove that these two triangles are similar. Okay, so let's have a look at how we would do this example. Okay, so I'm going to start off by stating the two triangles that I'm working with. So in triangle VWZ, and triangle, so now V is opposite the shortest side. So here's the shortest side, the angle opposite that is Y, so Y goes first. Then W is opposite the longest side. So here W is opposite the longest side as well. So W goes next. And then X is going to be last. Okay, so in triangle VWZ and triangle YWX. Now we have to have three statements. Just like we do when we're proving with angle, 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 we're still going to have three statements. So we're going to have 1, 2, and 3. But our statements are going to look a little bit different when we're working with proportion. We're not going to have reasons here because we're not saying that something in the one triangle is equal to something in the other triangle. It's a little bit different. What we're going to be doing is we're going to be taking a side in this triangle, putting it over the corresponding side in the other triangle, and seeing what we get. So I'm going to say VZ, so I'm going to say VW over YW. So let's go and see. VW is 12 over YW is 20. And then we need to go and simplify that. Okay, so 12 over 20, 4 goes into 12 3 times, 4 goes into 20 5 times. So I get 3 over 5. Now we need to go and do the next pair of sides. So WZ and WX. So WZ over WX equals. WZ is 6, WX is 10. So I've got 6 over 10. 2 goes into 6 3 times, and 2 goes into 10 5 times. Right? Now I've simplified that. Now we're going to do the last pair of sides. So VZ over YX equals. So over here, VZ is 15 over YX is 25. 5 goes in there 3 times. 5 goes in there 5 times, which gives me 3 over 5. So now if you look over here, for all 3 of these fractions, I ended up with 3 over 5, 3 over 5, 3 over 5. Now because those all gave me the same result, I can say that these two triangles are similar because their sides are in proportion. Okay, so now I can say, therefore, triangle VWZ is similar to triangle YWX, and my reason is sides of triangle in proportion. Okay, so that's how we do a proof when we are proving that triangles are similar using the sides that are in proportion. Okay, so first you open up in the normal way by saying in this triangle and that triangle. Then you have 3 statements over here, but these statements are going to look a little bit different to normal. You take the sides in the two triangles that match, you divide the one triangle by the other triangle, and you simplify. And you do that for each of the pairs of sides. Be careful, make sure that you always have the same triangle on the top and the same triangle on the bottom. If you had mixed up, so if you put wx over wz by accident over here, you would have ended up with 5 over 3 instead of 3 over 5, and then it would look like they're not in proportion. So you need to make sure that you are consistent with which triangle you put on the top and which triangle you put on the bottom. I recommend always just putting whichever one you named first, put that on the top, whichever one you named second, put that on the bottom, so that you know you're always going to do it the same. Okay, so once you've done that and ended up with the same fractions for each, you can then say that they are similar because the sides of the triangles are in proportion. Once you've done that, you can then go and draw conclusions. Just like we can when we're proving similarity using the angles, we can then go and say that the sides are in proportion. We can now go and say, because we proved they are similar using proportion, that the angles must then be equal. So now I can say, therefore, angle, remember I was wanting to prove that these two angles are equal or that these two angles are equal, because in order to prove that these two lines are parallel, I need to know that the alternate angles are equal. So now, because I've proved that these two triangles are similar, it means that their corresponding angles must be equal. So I already know that these two are equal, but that's not going to help me because that has nothing to do with these two sides over here. So this angle over here, V, I can say must be equal to that angle, Y, because these two triangles are similar. So I can say, therefore, angle V is equal to angle Y, because I know that the two triangles are similar. And the fact that those two angles are equal means that these two lines over here must be parallel. So now I can say, therefore, VZ is parallel to XY, and my reason that I can say that is because these angles that I just proved are equal are alternate angles. And if the alternate angles are equal, it means that the lines must be parallel to each other, because alternate angles will only be equal if the lines are parallel. So because these two angles are equal, which are alternate, it means that those two lines must be parallel. So now I can say that those two lines are parallel because the alternate angles are equal. So that's how we would do that question. Right, now I'm going to give you a few that you're going to do for yourself. Here's the first one that you're going to do. In this example, you need to determine the values of the unknowns. So you need to find the value of x and y with reasons. And they've told you that all the measurements are in centimeters. I'm going to give you 5 minutes to do this question. Okay, so let's go through that example and see what you should have got. Right, so first of all, if we need to work out what x and y are, then we have to prove that these two triangles are similar using the angles, because x and y are lengths of the sides. So I can only use proportion to prove similarity if I know all of the sides already. So I can't use the sides in proportion to prove similarity here. I'm going to be using the angles, which means that I need to be able to prove that at least two pairs of angles are equal to each other. So if we look at what we've got over here, angle O1 and angle O2 I can prove are equal because they are vertically opposite. And I can prove that because these two sides are parallel over here, I can prove that this angle is equal to that angle because they are alternate to each other. And I can also prove that this angle is equal to that angle because they're also alternate to each other with those sides parallel to each other. Okay, so I'm going to go and start my proof by saying in triangle MNO, and triangle, then over here M matches P, so P goes over here, then N matches Q, and O matches O. Right, so I've got in triangle MNO and triangle PQO. Now I'm going to go and put my first reason where I can say that angle O1 is equal to angle O2, and the reason that I know that they're equal is because they are vertically opposite angles. Next, I can go and say that angle M is equal to angle P, and the reason I know that they are equal is because they are alternate angles with MN parallel to PQ. And then finally, I can say that angle N is equal to angle Q, now I have two possibilities for my reason over here. I could say that they're equal because they're alternate angles because of the parallel lines. Okay, so that's one possibility. Another option is to say that they have to be equal because they are the third angle of the triangle. So you can choose which one you want to do. You can prove it based on the fact that they're alternate angles, or you can say that they must be equal by default because they're the third angle of the triangle. I'm going to use the alternate angles option, but if you used third angle of a triangle, that's fine as well. So alternate angles with MN parallel to PQ. So now that I've got three pairs of angles that are equal, I can say therefore triangle MNO is similar to triangle PQO, and my reason is angle, angle, angle. Now that I know that they are similar, I can go and find the values of those unknowns. So now I'm going to go and find the value of x and y by using the fact that similar triangles must be in proportion. So now I can say, therefore, the sides must be in proportion. So MN over PQ equals NO over QO equals MO over PO. And again, just like I said when we were doing the proof earlier, you need to make sure that you always have the same triangle on the top and the same triangle on the bottom. Okay. Now I'm going to go and fill in the values that I know. So let's go and see MN. MN is 8. So that's going to be 8 over PQ is 20 equals. Then NO is Y over QO, which is 25, equals MO is 14 over PO, which is X. Okay, so now I've got my three fractions equal to each other. I need to simplify this over here. It's not as simple as it can be. I'm going to simplify it. It'll make it easier for me to do my calculation. So 8 is divisible by 4. 4 goes in there twice. And 4 goes into 25 times. So I get 2 over 5 equals. Then these are going to stay as they are. Y over 25 equals 14 over x. So now I need to take this 2 over 5 and make it equal to each of these fractions so that I can work out what y is and what x is. Okay, so first I'll do x. So I'm going to have 2 over 5 equal to 14 over x. And now I'm going to go and solve for x. My LCD here is 5x. So I multiply by x on this side over here because I don't have an x in the denominator. So it's going to be 2x. Equals 5 times 14 is 70. Okay, so I have 2x equals 70, so therefore x must be equal to 35. And these are in centimeters, so that's 35 centimeters. Okay, now another way of doing this, instead of working out the LCD and thinking of it in terms of the LCD, another way that you can do it is to cross multiply like this. So we multiply over there. 2 times x is 2x, 5 times 14 is 70, and that it is actually still doing the LCD. It's just a different way of thinking about it. So it just makes it a little bit easier. So here I was just multiplying. 5 times 14 is 70, 2 times x is 2x, and then you divide by the 2 to get x on its own. Right, so now I know what x is. Now we're going to go and work out what y is. So again, I take the fraction where I know the whole fraction. So it's going to be 2 over 5 equals y over 25. And now I'm going to go and solve for y. Again, I can do the LCD where I can say the LCD here is going to be 25. Or I can cross multiply. It's up to you which method you want to do. Okay, so if I cross multiply, I'm going to have 25 times 2, which is 50. And 5 times y is 5y. So I have 50 equal to 5y. Now I can divide by 5, so therefore y is equal to 10 centimeters. So now I know that x is 35 centimeters and y is 10 centimeters. So that's what you should have got for that question. Right, now let's go on to question B. In question B, you have to prove that AB is parallel to EC and AC is parallel to ED. I'm going to give you 4 minutes for this question. Okay, so let's go through that question. Right, so our goal is to prove that this line and that line are parallel, and to prove that this line and that line are parallel. Now remember, in order to prove that lines are parallel, we have to prove that alternate angles are equal, or that corresponding angles are equal, or that co-interior angles are supplementary. So over here, I don't have alternate angles that I'm going to be able to work with. I have corresponding angles that I can work with. I've got this angle over here and that angle, they are corresponding. So if I can prove that those are equal, then I can prove that these two lines are parallel. And I've got this angle over here and this angle for these two lines. If I can prove that they are equal, then I can prove that those two lines are parallel. So those are also corresponding angles over there. So my goal is to prove that these angles are equal and those angles are equal. In order to prove that, I first need to prove that these two triangles are similar, using the lengths of the sides that they have given. Okay, so I'm going to work in triangle ABC. And triangle ECD. Okay, first I have AB over EC. So AB I know is 15 and EC is 5. So that's 15 over 5. And that gives me 3. Right, number 2. BC over CD equals. So BC I know is 12 and CD is 4. So I've got 12 over 4 and that gives me 3. And then the third one is going to be AC over ED. Okay, so AC is 24 and ED is 8. And that also gives me 3. So because I got the same thing for each of the pairs of sides that I was making into a fraction and comparing, I can now say that these two triangles are similar. So therefore, triangle ABC is similar to triangle ECD. And the reason I know that is because the sides of the triangles are in proportion. Okay, now because I've proved that they are similar, I can then conclude that their matching angles must be equal. So now I can say that angle B must be equal to angle C2 in the diagram over here. So I can say, therefore, angle B equals angle C2. And I also can say that angle C1 is equal to angle D. I can say both of those things because I now know that these two triangles are similar to each other, so their matching angles must be equal. Now, because angle B is equal to angle C2, these two angles are equal, they are corresponding angles. So over here, this angle and that angle are corresponding angles, where this is my transversal and these are the two parallel lines, or these are the two lines that it's cutting through. Because these two angles are equal, it means that those two lines must be parallel. So I can say, therefore, AB is parallel to EC. And the reason I know that is because the corresponding angles are equal. And I can also say that AC is parallel to ED because these angles over here are corresponding, and I just proved that they're equal. And so if these lines over here are being cut by this transversal over here and resulting in equal angles, it means that those lines must be parallel. So I can say that AC is parallel to ED as well. for the same reason, because their corresponding angles over there are also equal. And that's what you should have got for question B. Right, let's go on to the last one for today. In question C, you have to determine the values of the unknowns with reasons. So you have to find the value of x and the value of y, and you're being told that all measurements are in centimeters. I'm going to give you 5 minutes for this question. Okay, so let's go through that question and see what you should have got. Right, so first of all, our goal here is to work out the size of x and the size of y. In order to work those out, we have to first prove that this triangle ABE is similar to this triangle ACD over there. Okay, so we need to prove that those are similar. So in triangle ABE, and triangle ACD, I can say, number one, that angle A is common. The two triangles share that angle A. Okay, so angle A is common. Then my next thing that I can say is that angle B1 is the same as angle C because they are corresponding angles with BE parallel to CD. So angle B1 equals angle C because they are corresponding angles with BE parallel to CD. Okay, and then my third statement is going to be that angle E1 is equal to angle D. Now I can use the same reason that they are corresponding with these two lines parallel, or I can say that they are equal by default because the other two sides in the two triangles are equal, then the third angle in each triangle has to be equal as well. So I'm going to say over here, third angle of triangle. But if you had had the same reason, again, corresponding angles with BE parallel to CD, that would be fine as well. So now I can say, because I've got three pairs of angles equal, I can say, therefore, triangle ABE is similar to triangle ACD, and my reason is angle, angle, angle. Okay, now that I've got that, I can then say, because the two triangles are similar, it means that their sides must be in proportion. So therefore, AB over AC must be equal to BE over CD, which must also be equal to AE over AD. Okay, so now I'm going to go and fill in what I know for those. So AB I know is 6. So that's 6 over AC. Now I don't know a value for AC. I've got 6 and I've got Y. I'm going to ultimately want to work out what Y is, but I can't just call it Y. I would either have to write 6 plus Y, or I can keep it as AC and then work out what Y is later. That's what I'm going to do because it's going to be easier than working with more than one term in the denominator over here. So I'm just going to write AC. I'm going to keep it as AC and I will work out what AC is, and then I will work out what Y is afterwards. Equals BE over here is X over CD, which is 15, equals AE is 8 over, now AD is 8 plus 4, which is 12. Okay, so now I've got my fractions. Now I need to go and simplify this over here. So that's going to be 6 over AC equals X over 15 equals 2 goes in there, or 4 goes in there twice, and 4 goes in there 3 times, so it's 2 over 3. So now I'm going to take each of these fractions and make them equal to 2 over 3 so that I can work out the unknowns. So I have 6 over AC equal to 2 over 3, and now I'm going to cross multiply. So I've got 6 times 3 is 18 equals 2 times AC is 2 AC, and then I'm going to divide by 2 to find out what just AC is. So therefore AC is equal to 9. Now I didn't want to know what AC is, I want to know what Y is. So now remember, AC is made up of AB and BC. AB is 6 and BC is Y. So AC is 6 plus Y. So now I can say that 6 plus y is equal to 9. Which means that y is equal to 3 centimeters. Now I also need to go and work out what x is. Okay, so I'm just going to do it over here because I'm running out of space. So I'm going to say over here, x over 15 is equal to 2 over 3. Now I'm going to go and cross multiply. So 3x equals 30. Then I divide by 3, so therefore x is equal to 10 centimeters. So now I know that y is 3 centimeters and x is 10 centimeters. And that's what you should have got for that question. And that's how we prove that triangles are similar and use their similarity to work out other values. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.